Hi, welcome to Fun Pi videos. This is DC here. This is the second video on PN5321 Mifare Classic EV1. Now this video is about PN532 commands for Mifare Classic EV1. Now what you're going to learn in this video is all the PN532 commands that are specific to Mifare Classic EV1. You need a copy of a PN532 user manual or application note. Both these you can get it from the manufacturer website. Now this video is a bit of a technical side, so this will be useful for software developers or students of technology or the tutors who teach Mifare Classic cards. In this video I'll be using a Arduino board. In the last video I have used a PN532 board, and this is also a very similar, but this Arduino board, it's a Arduino and PN532 all-in-one board, and this is good for the students or who are trying to integrate the systems. Say for example, if you are creating or designing your own access control system, so Arduino board is going to help you because it has got both Arduino, which you can use to program and keep all your business logic, and the PN532. You can see here I've connected my Arduino board. This board comes with an external antenna. The red is the antenna bit. I've made few videos on how to use the Arduino board and the PN532. I'd advise you to look at those videos. And I'm using this software, the same software I've been using in all my previous videos. So this is version 1.95. If you look at here, I've already clicked on connect to PN532, and here it says the board is connected to COM6, and this is the firmware version of the board. So now we are ready to look at the various commands. So I'm going to keep a paper bridge so that I don't have to keep holding the card always. And this was the card I've used in my previous videos. So choose the classic 1K, 4K and activate. So in this video you're going to see what all these commands are. Now the very first command, or before that, the PN532 board is running in a UART mode or the HSC mode. The first thing you have to do is you have to send this the SAM config and the wake up and the SAM config command. Now if you look at the documentation, is mentioned the byte format of the wake up command. It's 5555 followed by a series of zeros, and this is followed by the SAM config command. Now this is the very first command you will see if you look at any PN532 and Arduino libraries. And we still I'm not sure why it is 5555, but one thing that comes to my mind is because this is kind of a wake up signal. If you convert the 55 to binary, you'll end up having 0 1 0 1 0 1 0 1, and if you draw the digital wave for this, you'll end up getting a series of 0 to 1 type of pulses. This could be the reason why they've chosen 0505. Now after that you have to specify what's called as the maximum retries. So this again documentation explains what exactly this does. So put in simple words, so I'm telling the PN532 to not to wait indefinitely for the card. So that's what it's all about. You can if you set the value of FF or some number, the documentation says you're keeping the PN532 in an infinite loop, waiting the card forever. The next is the most important command. This is the command that does the activation. So all the series of sequence of commands like sending the REQA, doing the anti-collision, step 1, step 2, and selecting the card, it's all put inside this firmware command called inlist passive target. Now here I'm telling this command to look for the type A card, because Mifare Classic is a type A card. So because PN532 also works with the type B, but keep in mind doesn't work with the ISO 15693 tags. So the output of this is, so it tells you whether the card is detected. If it's detected, it gives you the UID of the card. So all the information is stored here. So some of the important bits, piece of information here again, this entire command bytes are explained in the documentation of PN532. Now here 01 means one card is detected, and 0044 means this is of type the Mifare Classic 1K, and this is followed by this is the UID of the card. Now this is a 7-byte UID, so you got 7 bytes here. So this is what is shown here. So these things happen every time you hit this activate button. Next, and I'm not going to read this entire tag. Probably I might have changed the keys of some of these sectors. I'm going to choose, say, sector 10. I'm going to authenticate. Now authentication successful. Now if you look at the series of the commands that are going here, now this authentication is done by using in data exchange command. Now I'm going to show you the documentation as well. Now this is the documentation of PN532. If you look for the section in data exchange, and this is the command you'll be using most of the time with Mifare Classic. And if I scroll, now again, okay, there are more information here. It's a D440 and the tag ID, and the data out is where you send this Mifare Classic commands. Now if you scroll down, there is a section that says Mifare card, and this section explains what should be the data command, and all the commands that are available is mentioned here. So these commands more or less map to the commands that you find in the Mifare Classic EV1 cards. Now keep in mind, these are the commands, or these are the firmware commands. Now they don't have to match one-to-one with the card command. So however, so the most important commands we need is, we need a command to authenticate using key A or key B, and you need a command to read 16 bytes or write 16 bytes, and you need a command to do the increment. This is for the value blocks, or a decrement, or the transfer, or the restore. These are the only commands you need to access Mifare Classic EV1 tags. And if you scroll down further, there is an example on how to use it. Now only thing what you have to remember is, in authentication you have to send the last 4 bytes of the UID, not the 7 byte. So that's exactly what's happening here. So going back to the command used, so now we know it's the in data exchange command. That's the main command here. Inside that you have to send the authenticate command. Here I'm authenticating using key A, so it's 60. I'm authenticating a block in sector 10, so that is 28, and this is followed by the key value, and this is followed by the 4 bytes of UID. So this is the last 4 bytes of the UID. So it is from 2A to 80 is what you have to send here. Now this is the data you get from the anti-collision 2. The first 3 bytes you get from anti-collision 1, and the remaining bytes you get from anti-collision 2. So you just have to keep in mind that if you're using a Mifare EV1 7-byte UID, you have to use the last 4 bytes for the authenticate command. Now again, this command will return a success or a failure in this status byte. It's a 00, it's a success. So I'm going to read the entire sector. There's a read sector here. Now all the 4 bytes are read because this is a Mifare Classic EV1 1K. There are 4 blocks in this sector. If you look at the various commands that are going here, again it's the same in data exchange. So this is the command to read. The command to read the block is 30 followed by the block address, and this returns the status byte 00 followed by the 16 bytes of data. Again here the next is the block address 29. See, these are the physical block addresses. So if you look at this here, if you look at here, this is also, this is actually what you see here is on the screen is the decimal, but here is a hex code. So here 28 hex code is 40 block address. Okay. So again, there's a sequential read access starting from block 28, 29, 2A and 2B. This is the last block. In all these four cases, you have a status equal to 00, 00 followed by the 16 bytes of data. Now this is what is explained in the user manual as well. Now in order to write it, I'm going to clear this. Now I want to change the value of this block, so I can just use this a quick editing autofill this block, set this as AA. Now since I'm in this sector, it's already authenticated, so I don't have to do any more authentication here. So I'm going to hit this W button. Now this is you can see a message that says write block 40 OK. Now if you look at this commands here, the command used to write this block is A0. If you go back to the documentation, it is write 16 bytes here. It's A0 followed by the block address followed by all the 16 bytes you want to write, and the response should be the status with 00. So you have to check for the status byte 00. Now this is a successful write. So likewise you can also assume that you're changing access rights. Now there is no a separate command to change the access rights. I'm not going to explain these access rights here. However, I'm going to keep this access rights of sector trailer to 1 so that I'll get a chance to revert this back. So if you look at here, as soon as you change the access rights of all this block, the screen shows the new access rights, but you have to write it. If I say write, so there's a warning here. Okay. Now again, there is no separate command to write sector trailer block. It's just just a write operation. So it's the same A0 and 28 that writes the sector trailer. If you try to read, probably now what I'm going to do is I'm going to say close this, activate and read the sector 10, authenticate, read the sector. You can see that all the access rights are back to 11. The next thing is I'm going to revert this access rights back to the default factory setting, right, and say write this thing. Okay. So the next thing is about the commands that are used for doing the value block operations. That's also called as a parse operation. So before the value block operations are used, the data block must be in the value block format. So I'm going to right click here and say value block. I'm going to have a default value of 1000 and also going to have the block address as backup address as 40. So I don't want to spend any time explaining the value block operations, so that I'm going to do in my next video. So now we have got a value block. I'm going to write it. The write is successful. So I'm going to increment this value block. So you can clear this. So I'm going to increment by 10. Now for the timing, I'm going to remove this auto transfer. So I'm going to increment. If I hit this increment, now what has happened here is this is the increment value block command. So if you look at the documentation, this is the increment, this is C1. You have to know the additional parameters you're going to pass here. There are a few examples in this documentation. Now you're going to increment. Obviously you have to mention which data block you're going to increment, and also you're going to pass the value of the value you want to increment. The values are 4 byte sign number, so which is I've incremented by 10, so it's 0A followed by 3 zeros. Now again you have to look for the success status here. Now the way this Mifare Classic works is, so it has got, so the incrementing is done in 2 steps. First, the number is added to the value block, and the result is stored in a temporary place, which is referred to as a volatile memory. This again in the card. Now my volatile memory is 1010. I'm going to, in order to write the result back, so you have to issue the transfer command. So I'm going to hit the transfer. If you look at here, now this is the transfer value block command. Again the command is B0. This is what the documentation says, it's a B0. So after this, after the transfer block, again you have to check for the success byte here, 00, and the software tries to read the block again. Now this is the value that's read, and you can see that there is a change here. So in order to know the new value, I'm just going to hit this read. Now you can see that the value now is 1010. So I'm going to do decrement. I'm going to decrement the value by not this much, 100. So decrement, the result is stored in the volatile memory. That is, if you look at the command, the decrement value block has a command of C0 followed by the block address followed by the value you want to decrement. The result, the software shows the result. There's no way you can read the value of the volatile memory. There is no command to do that. Now just the software simulates that. It just decrements the value by value from here and shows the result. So this time I'm going to transfer the result not to the same block. Just for the sake of learning this transfer command, I'm going to transfer to 41. I don't think you will ever do this in a real application because you want the value to go back to the same thing. Now I'm going to transfer the result to the block address 41. So transfer. Now it's transferred here. If you try to read, you got the value 910. So there is 100 less than the. If you look at this number, this still has the original value. So we have transferred the result to block 41. So the next thing and the last command you're going to know is the restore block. Now this is the command used to read the value block into the volatile memory. So assume that I want to copy the value block from here to here, from 41 to 42. Now if you just want to do this, you can read it and then write it back, but now there is a command to do this thing, restore. So because restore will also copies the data in the value block format. So I'll show you what it is. So 42 block has got all the bytes as 00. What I'm going to do is I'm going to restore or read the value of this value block into the volatile memory. Restore. It's just the software is trying to simulate this because, as I mentioned before, there is no command to read the volatile memory. Now I want to transfer this to different blocks. So if we hit here, then say transfer. If you look at that, now this is what the Mifare Classic card has done. So it has copied the value. The value is in the value block format. If you try to read the value, you can get that. Okay. I think these are the only commands are available to operate with the Mifare Classic and EV1. So if you want to do anything else, like for example Mifare Classic EV1 can be personalized. So all these personalization are all done using the basic commands like a authenticate, read or a write. If you want to do authenticate with the with the block B. Now I'm going to show you that as well. So authenticate with key B. So authenticate. Now authentication is successful, and here the command used is 61 followed by the block address followed by the key and followed by the last 4 byte of the UID. Okay, I think this in this video we covered more or less every commands related to Mifare Classic EV1 using a PN532. Thanks for watching.